Thanks very much. Hello everyone. I'm Aftab. A bit of a background about myself. So I got exposed to semantic technologies back in 2008. Since then, I've been working with semantic technologies and built knowledge graph for several domains, including software engineering, healthcare and life sciences, government domains, and quite recently in the finance sector, given that I'm working for JP Morgan. So at JP Morgan, I design and implement critical services and solutions in order to implement data governance and data management solutions in order to support or to make sense of JP Morgan's data landscape. The reason I'm here today is to share with you our data strategy at JP Morgan and how we implement data governance and data management solutions within a specific line of business at JP Morgan. Data is the lifeline of an organization. Without data, applications are of no use. Therefore, we treat data quite seriously and put loads of effort in terms of making it a first-class function in order to address or achieve our three key objectives, which are generating business value, be compliant with regulations, and reducing barriers to access. In the line of business which I am part of, there are more than 1,000 applications currently operating. For all those applications, we have identified 80 million distinct database columns in 2 million different database tables. No one has any clue how these numbers actually comes up, which applications are using that many number of distinct database columns and tables. So having this well described goes a long way in terms of generating business value for the firm. As a financial institute, we are faced with an increasing number of rules and regulations, such as GDPR, new privacy law in India, and quite recently CCPA, which is California Consumer Privacy Act 2018. Financial as well as technological regulations are getting complex day by day. Therefore, we spend a huge amount of time working closely with data regulators in terms of explaining them the data and reconciling our data sets. Having a well-described data environment would allow us to perform consistent reporting and ultimately safeguard our as well as clients' data. And last but not least, we want to make it relatively easier to get access to the data within the firm. We had a consultancy firm who observed our knowledge workers and developers, and they found out that most of us spend 60% of our time finding the data and only 40% of the time in leveraging that data. We want to flip that ratio in the opposite direction. We have and continue to invest a lot in several key themes to our data strategy. To be more specific, let me give you some examples. For example, data protection. The basic rule of thumb when it comes to data protection is we should never have sensitive data in lower environments. Therefore, we must identify sensitive data in lower environments. And once identified, we must protect it. And once protected, we must validate that our data is completely safeguarded. Most of the applications in JP Morgan handles data for multiple countries. Therefore, there are several regulations that apply to applications. And ultimately, applications are supposed to handle the data within their respective storage layers for a certain period of time, after which they must dispose or archive the data. Therefore, this is where regional compliance helps the application owners as well as applications to manage what regulations are applied to them. Application owners uses regional compliance and records management in order to identify what are the regulations as well as data retention policies that are applied on the data. And once those are identified, they leverage our archive service capabilities to actually securely archive the data in a private data cloud, which JP Morgan owns. And archive service does not only allow you to archive the data, it also allows you to retrieve the data securely. Let's say if tomorrow a regulator comes in and asks for data from 2012, then archive service capabilities allows us to actually bring the data dated back in 2012. On the data lake, so JP Morgan has its own data lake, and therefore we have working quite closely and extensively on providing the right tools and frameworks in order to implement strict processes and governance around our data lake. So now coming back to the basic question, why data management? We all work with data, right? And therefore data management is for everyone, be it a software developer, a business analyst, or a compliance manager. So let's imagine that I'm an application owner, responsible for an application that handles loans data. Therefore, I must document what data my application holds, where I am getting the data from, who I am sending data to, and how the data is being used by the downstream applications. All of this is covered as part of data management principles as well as processes. Now imagine tomorrow I would like to bring in mortgages data into my application, and I might be thinking of building it on my own. And there is nothing wrong with that, but I will explain why it is wrong. So tomorrow some other teams might build similar data sets, and what will happen that you will be replicating the same data set across multiple teams. Therefore, one of the key aspects of data management is to rationalize your data models as well as your data sets in order to reduce ongoing cost of ownership. Therefore, at JP Morgan, we want to make it relatively easier for our end users or for our developers to find the right data among hundreds of petabytes of data which we currently have in JP Morgan. So therefore, because we have a humongous amount of data currently in JP Morgan, it becomes really hard to find the data. So that's why our vision is to make data a first-class function. And why that is the case? Because better data leads to better information leads to better decisions, and better decisions leads to business value. And how we actually do that? We have data standards defined. Those data standards are translated into business glossaries, into taxonomies that describes those terms. And then we have processes in place which actually allows applications to build logical models in order to represent their physical data models. And last but not least, we have the data catalog on top of that, which allows our developers or knowledge co-workers to search for the data, search for strategic data. And finally, this can then feed into several artificial intelligence or machine learning tasks to address several use cases within the firm. So in order to support our vision, we must collaboratively define our data landscape, right? And therefore, in JP Morgan, we have defined 5 key data governance capabilities that flows from 5 different questions. What data do I need? If I have to bring a new data into my application, I must document the data requirements. What sort of data I need in my application? Where should I source the data from? What data do we have? It's more about data in place. What sort of data your application is currently holding? Is it loans data, mortgage data? What are the domains your application currently covers? Where is my data coming from? What are the upstream applications which are sending data to my applications? And where should my data come from is more about if we are actually getting data from the authentic data source, or we are getting data from a non-authentic source. And finally, what data should be shared most? It's more about reference data, the data which is have authenticity attached to it, and that everyone within the firm should use that data. So I would like you to keep in mind the data in place and data in motion, because you will see some examples where how we actually map this data in place and data in motion currently in JP Morgan. So in order to properly manage our data, there has to be a life cycle attached to it, similar to why we have a life cycle for software development, right? So therefore, if we are to create a new data, we must first ask questions: do we really need to create data ourselves, or we can source data from an upstream application, which is okay? We need probably battery power. And how much data are we storing within the application? Are we using the data for some analytical purposes, or it's just redundant data? If it's redundant data, then we should archive it or discard it, because our ultimate goal is to reduce the digital footprint within our application. As I mentioned, we have hundreds of petabytes of data already in the firm, so we have to proactively look into all those aspects. Is it absolutely necessary for me to share the data? If I am not the authentic data source for some data, then I should never share data with downstream applications, but rather downstream applications should get the data from the original source. And once the data is no longer needed, then I should archive my data because there are regulations, retention policies that are applicable to applications. And ultimately, I should destroy the data at the end. So the metadata, which is right in the middle, it plays a key role in this whole data lifecycle, and we capture all the meta information during all these 6 different parts of the data lifecycle into our metadata, and this is where we actually bring the knowledge graph capabilities in JP Morgan. So how we do that? So on the left hand side, we have all our JP Morgan application landscape, which are actually providing their digital their metadata footprint into several, or I would say dozens of different software frameworks or repositories where they actually put meta information about it. What we do, we actually extensively work on defining schemas for each of those source systems. And once we have the schemas in place, then we actually extract information from those data sources in order to build our knowledge graph. Let me give you a concrete example at conceptual level, talking about how we actually map the data in place side of in JP Morgan. So in order to map our data landscape on the logical and the physical level, it all starts at the very high level with business terms. So that's definitely very high level because in JP Morgan, everyone uses those business terms so that we speak the same language. So if I want to bring data into my application, then I need to provide some data requirements along that, and in that I should be documenting what are the business terms which actually defines the data concepts, the data domains that my application would require. This gets translated into a logical data model where an information architect or an application owner or a data modeler take those requirements and implement the necessary changes to your logical data model, or in the form of defining adding new entities and attributes. And finally, this gets reflected into your physical data models, where those entities get translated into your tables and into database forms. Now, if you see this red line going from top to bottom, this is your data traceability. It actually shows you how data is flowing from business term all the way down to PDM. So that one way to capture the data in place part of JP Morgan. How we actually capture. For example, tomorrow if we have to define why do I have table X in my application, then having this kind of meta information captured, we can follow all the way to the top. This is how it comes into existence at first place. Yes.
Am I allowed to ask a question, or do you want to keep it to the end?
Yeah, I mean, no, you can ask us in the end.
I'm intrigued why requirements are sitting in the middle of this. I would have expected the top 2 layers to be inverted. Is it an intentional thing, or is it?
No, so business terms are actually calculating the business glossary of JP Morgan.
Okay.
And that's kind of like, a standard. It's considered to be the data standard. So it always has to be at the top. So if you want to bring some sort of data, you always have to map it to your glossary, your business glossary within the firm. So business terms considered to be your standard, which are defined for JP Morgan and similar for other corporate sector, other companies that do the same. They have a high level business glossaries or taxonomies that they have defined, and you do make use of that in order to extend your application, bring data into your applications. Right, so this is kind of the flow that you have in place when you're actually working one application, but obviously then the data actually being translated because application A might be sending a data to application B and application C, right? So this is where the data lineage part comes in. The purple line actually tells you the data lineage. We have several lineage tools that harvest that information, spits out that information, and we bring all that meta information as well in order to build our knowledge graph. So now that we have built this whole pipeline where we actually bring data into a knowledge graph, there are several insights you can actually take. You can actually run on top of your knowledge graph in order to unveil some interesting facts. So what I'm currently showing you is the simplest form of computing the application complexity. Remember in the beginning I mentioned that we have 80 million distinct database columns within 2 million database tables, and we have no clue how those numbers actually add up. So this is one simplest way of computing those results. We just plot it in the form of scatter chart, and there's some normalization in place that there are some applications which have more than 60,000 columns as well as attributes. We do compute several other, we take into consideration several other indicators in order to compute our application complexity, but this is the simplest form of it. Where things gets more interesting is when we actually try to do the data lineage side of things. So what you currently see is our data lineage diagram, where on the far right is one application, and this application is actually getting data from 4 different source systems. So this is your application, and these are 4 upstream applications which are actually sending data to this particular application on the right hand side. And if you look into the different colors, so different pipes means different colors. For example, the green one tells you that there is logical data flowing between applications. By logical flow, I mean the information architect or the application owner has defined that, let's say, I'm sending loan data from incoming Swift application to Sage. The blue line tells you the physical flow, which we actually compute by looking into the ETL jobs and the APIs which are responsible for sourcing and consuming data. So this actually explains you what are the physical flows that are going based on the APIs, communication between applications, what sort of data is going into it. And the black line or the black line tells you the combination of both, that there's a logical flow happening as well as the physical flow happening between these 2 applications. And it becomes even more interesting when you click on one particular pipe, that you are able to see the inner details of what exactly is going through from Tradeboard, the source system, into Sage. So in this case, it tells us that there's some entities which are being transferred from Tradeboard. In this case, is market execution. It's going into this application, and they are implemented on the physical level in the form of some APIs with some names which I've configured for privacy reasons. I've just marked them in this. So that actually gives you an overview between what an application is getting data from upstream applications, what are the logical flows, what are the physical flows that actually defines your data lineage between an upstream application, and we are able to do the same for downstream applications. And why we do that? So imagine that tomorrow Tradeboard goes down, then we would be able to quickly check what are the applications that are impacted by this. For example, if Tradeboard application goes down for some reason, then Sage surveillance is one of the applications which will be impacted because of the source system, and what are the information that will be lost on its way to the downstream applications. Right, okay, to sum it all up, so I have kind of explained you how we actually handling or how we are actually mapping our logical and physical data landscape at JP Morgan, and specifically how our approaches are in terms of bringing the data which is currently in place, data which is in motion, and the regulations. We bring all that data into our knowledge graph, and where we are working towards now is data profiles. By data profiles, I mean we have access to the subset of data that each application holds. We want to bring that that data as well into your knowledge graph, along with data in situation. So that will actually give you even more enriched information for our knowledge graph. Let me explain to you what data in situation is. So let's say you have an application and you want to send data to 3 countries in South America: Uruguay, Argentina, and Brazil, right? So the first thing that you need to identify is if those 3 countries are adequacy decisions, or if there are adequacy decisions in place for those 3 applications. Let's say Uruguay and Argentina have adequacy decision in place, but for Brazil it's not. So your application are able to send personal data from UK to Uruguay and Argentina, but in order to send your personal data, which an application holds to Brazil, you need to provide additional safeguards on your data, which primarily means kind of like providing more encryption in your data before you actually send data to application. So this is what data in situation is, and this is where lawyers and regulators, they work quite closely with us in terms of defining all those obligations and regulations. So we bring that data and massage it along with other information which we have in our knowledge graph. And once there, where we are now going with all this is to provide, to implement some machine learning and AI methodologies on top of that, in order to reduce the human intervention loop in terms of addressing several use cases where we are currently spending loads of time in JP Morgan, and a couple of them are to automatically identify and protect our sensitive data in lower environments, and to reduce the digital footprints by archiving the data and destroying the data automatically. So having said that, Thank you very much, and I'm open to questions.
Hi there, my name is Sheetal from HSBC. Thank you, that was really informative. The question I have is, how do you handle data that's in UDAs or EUC spreadsheets?
Sorry, data in?
Spreadsheets.
In spreadsheets.
Yeah.
Right, I know where you're coming from, but yeah, that's one of the painful thing we have, I guess everywhere. But currently, yeah, we work quite closely with the teams who are not like very spreadsheet savvy. But obviously, because the data never lives in a spreadsheet. It always comes from some source systems. Like in the example that I've given you earlier, that we have dozens of frameworks which are in place. So usually, people or co-workers, they can pull data from those into form of spreadsheet. They work on the spreadsheets. But now with this knowledge graph, we are actually trying to kill this whole exercise that they have in place in terms of working with spreadsheets. We want to get them out of the spreadsheet world and leverage knowledge graph technologies to actually get things done quickly.
Thank you.
The mapping, the logical mapping between the logical layer and the physical layer, is that automated to some extent in your model, or do you still require subject matter experts to make judgment calls on that?
No, so that is being done by the information architects. So for example, you are a data model for an application, so you define your logical data model and as well as physical data model, and you define the mapping between them. So that actually translates automatically from logical to physical, and how an entity is mapped to a table, and how an attribute is mapped to a database column. So that's being done as part of your modeling exercise. So if you're modeling in Magic Draw or Arvind, I don't know how familiar are you with the data modeling tool, so it's being done as part of that exercise.
And the logical model is, again, system specific. The only thing that's firm-wide is the business term.
Yeah. Because everything then you link back to the business terms. So at the logical attribute level, you always define this is my logical attribute and what sort of information it holds, and that ties back to your business terms.
I'm just a little confused. This is a question of clarity, really.
Right.
So you mostly talk about data management and your standards and practices of data management and life cycle. But really, in the end, you kind of came to a place of bringing knowledge graphs into the equation. And if you can open your, I think, second last or third last slide. Yeah, this one.
Oh,
this one. Right. So you're what I'm confused about is how are you really applying the AI and what is it doing? Because those two things that you've mentioned, they're kind of umbrella things, right? So in terms of business perspective, and also, so what really is in your knowledge graph? Because the things on the left are your standards and the things that you initially talk about. So how is that data going into the graph? What are the relationships between the data management standards that exist within the knowledge graph, and how is that feeded to the modules?
Right. So your data management is actually the schemas that we have defined for each of those frameworks. For example, if you are modeling regulations, then you define a schema for that, right? So that only defines the schema, what a regulation is. But what is this records for that regulation? Which applications are part of that? This is where we talk about the instance data that match with those schemas. So this is how you actually build your knowledge graph. So it's a combination of schemas as well as the instance data that we are pulling from several sources in order to build your knowledge graph. So the knowledge graph primarily consists of your schemas, your ontologies, along with the instance data which are mapped to it.
So what data is under which regulation, and
yes.
So how is it managed in our data centers or data storage?
Obviously, so there's a full connectivity and traceability among the applications. So for example, if you're looking into application A, so it will tell you, or not tells you what are the regulations that apply to your application, what are the data retention policies that apply to your application, what are the source systems from which you're getting data, what are the downstream applications you're sending your data. So all of this is actually embedded in your knowledge graph. All of that is actually in there.
Okay, and then how is AI helping you do the things that you're doing on the right? Because it looks like if you're identifying and protecting sensitive data, you can do it without AI, because you're aware of the regulations within the graph and even the
Yes, but again, I think I did mention that there's human intervention loop in between, and because application owners, they trigger certain jobs, and they look into the regulations, they make certain sense out of it, and only then they trigger certain ones. It's kind of like a bit of manual process to identifying those things and to reduce the digital footprint currently. So bringing ML and AI, so tomorrow if a new regulation, let's say, CCPA is something which is just around the corner coming up. So we have done those things for other regulations. So tomorrow CCPA comes in, then what we are focused on here is to leverage what regulations and different things we have done with GDPR or new privacy law in India. We replicate the same without spending too much time and so doing it manually for CCPA and do the same things there. So this is where
I understand. Thank you.
You're welcome.
I wonder how much of the regulations is formalized. You mentioned that applications and data corps are tapped, whether they are subject to certain regulation or not. But this is just making the connection to the regulation. But the regulation itself has a lot of content of what you should do, what you shouldn't do.
Yeah.
And I wonder if there is then somehow, like what sort of inference you have in the knowledge graph. For example, can you generate data flows or data flow constraints or exceptions, like you mentioned the case of Brazil? How much you can automate by using logical reasoning on the lineage?
Yeah, that's a really good question, and that's to say, so we are working quite closely with lawyers, and for lawyers, they understand the regulations much better than us, the technologies. So we work quite closely because these skim through, they go into the deeper of regulations and they identify bits and pieces, what are the obligations, and based on those obligations, what are the actions that need to be performed. And once we have that in place, then we actually define the schema accordingly, and we are kind of like working in that direction for CCPA specifically, because that's just something around the corner. We kind of learn from what we've done in the past, and we're trying to kind of like automate that process going forward, so that after CCPA, if there are new regulations that comes in, then we are able to kind of reduce or manual effort in that direction. But I know it's a complicated thing to do. Regulations, it's not always easy. That's what we are regulators.
Yeah, I wonder whether you use something like deontic logics of permissions and obligations, or use FIDO in any way?
No, we personally or not, but obviously I'm just representing one line of business in JP Morgan, but it could be other line of business or leveraging FIDO for that. But us, we are not at the moment. We have different set of schemas and moves.
We've got time for one more question. No? Any takers? Last chance? Great. Okay. Well, big round of applause for Aftab.